going to start our next chapter, that is backtracking. Up to now we have studied about recursion basics. In recursion basics we have studied like questions like Fibonacci series, tiling problem, friendship pairing problem, and all those famous problems. After that, in divide and conquer algorithms we have studied about merge sort, quick sort, and all those kind of things. So in this chapter we are going to talk about a new concept of recursion, that is backtracking. So the meaning of backtracking is we all go in a particular path, and if we found out that this particular path is wrong, then we will retrace to our original source and will like go from different direction or different path to find out the solution of a particular problem. This concept is known as backtracking, and the meaning of backtracking in English also is same. That is, we'll go in a particular path, and if we found out that this particular path is wrong, then we'll retrace to our original source, and from the original source we'll like try to go in another direction to find out our solution. So the meaning of backtracking in English also is same. Okay, now to understand the meaning of or the concept of backtracking, we have seen maze. So the in Hindi we called it as bhul bhulaiya. So in bhul bhulaiya or in maze, we have an entry point and we have an exit point. Okay, exit point and entry point. And in maze we have different directions, suppose I am starting in this direction, and I can go like this, like this, like this, and like, yeah, like this path. And if I found out that this particular solution is wrong, that is this particular chosen path is wrong, then I will retrace from my original path. I will retrace from here, and I will come back, and I will start from new direction. That is, I will start from here, new direction, like this. So I will go like this, like this, like this, yeah, and this is my another direction. Then if I found out that this particular path is also wrong, that is this particular path is also wrong, then I will retrace back. So this concept is known as backtracking. So I will choose one direction, and if that particular chosen direction is wrong, then I will come back to my like original source or the previous path, and from the previous path I will choose a new direction to find out the solution. So here at every point what we are doing, we are like choosing every direction. So we will go in every direction, and in each direction, if the particular chosen direction is wrong, then we will retrace, we will backtrack, we will come back to our original like source or original point. We will backtrack from the wrong direction to our original point, and we will choose another direction. We will choose another path or another direction, and by choosing another direction we will try to find out our solution. That is to find out the path between entry point and exit point. This is our solution in this maze, right? So we will try to find out the solution of that particular problem. So this is the concept of backtracking. Okay, so the concept of backtracking is very simple. If we are clear with concepts like recursion and divide and conquer algorithms, then backtracking is going to be like easy peasy for all those for all of us. And they are like famous questions in backtracking. If we understand around 2-3 questions of backtracking, then it is going to be like backtracking is going to be like very easy for all of us. So the famous questions in backtracking are N-queens, gridways, after that subsets. So these are the like three famous questions when it comes to backtracking, and if we like understand the logic and the working of these three questions, then it is going to be like very easy. The concept of backtracking will going to be like easy peasy for all of us. So let us start this chapter. So we use backtracking for mostly three kind of purposes. That is, first one is decision making. Decision making is nothing but whether the solution exists or not. Whether the solution exists or not. If it is like exists, then print yes. Or if doesn't exist, if the particular solution of the particular problem doesn't exist, then print no or false. So decision making. And the second one is optimized solution. If the particular solution is like existing, then give me the optimized solution among all the solutions set up. So this will give me like optimized solution, the best solution. After that, third thing is enumeration. Enumeration is nothing but all the possible solutions, solutions. So they are like three kind of backtracking, you can say. That is, first one is we have to find out whether the solution exists or not. If it is exist, then we'll have to print yes. If it doesn't exist, then print no. The second kind of thing is optimization. if the particular solution of a problem exists, then give me the optimized solution among all the solutions. After the third thing is enumeration. The meaning of enumeration is print or give me all the solution set that are possible for my particular solution. So to understand these kind of what is decision, what is optimization, what is enumeration, let us take example. So to understand the concept of all three kind of different types of enumeration, backtracking, let us take example of grid. So this is my grid. Yeah, let us consider that this is my grid and this point is 0 comma 0 and our grid is m cross n. So this point will become m minus 1 comma n minus 1. Okay, so there are m minus 1 rows and n minus 1 rows. So we are starting from 0th row. Okay, so this is my starting point, this is my starting point and this is my ending point. So in this question, let us consider that I need to find out the paths which are possible to go from starting point to my ending point. So this can be a path. Let us consider this is our first path. So I can go like this, up, down, left and again right. So this will be my first path. After that I can go like this also, like this also, I can go like this also, I can go from the here to here. So this is like looking kind of messy, but you got the point, right? So the solution exists. So we will first of all, if the question asks us that whether the path between starting point and the entry point exists or not, give me just whether the solution exists or not. Then you will use decision in this. If the solution, if the problem asks you that give me the optimized path, then the optimized path will be this. So we will give this path as my solution. After it, if the in the solution in the problem user has asked us give me the all possible ways, then we will return all the possible ways. So how many possible ways? For example, 1 2 3 4, and let us consider around there are like 6 ways that are possible from the ending point to starting point. Then we will print 6 to our user. If user has asked to optimize solution, then we will print 1. If the user has asked just tell me that whether the solution lies or not, then we'll print yes if exist, no if no, then our solution doesn't exist. So this is the three types of backtracking, different kinds of backtracking. So number one, decision. So in decision what we'll do, we'll see whether the solution exists or not. If it is existing, then we'll print yes. If it doesn't exist, then we'll print no, as simple as that. And the second one is optimization. So among all the solutions which are possible, we need to return to my user which is the optimized solution. And the third one is enumeration. Enumeration is nothing but giving all the solutions that are possible. So to understand how backtracking works and how we can code the logic and all those kind of things, let us do a simple problem. So to build the understanding of backtracking, let us do a sample problem. Let us consider that this is my array and I need to fill my array using functions or using recursions. Okay. So initially at I is equals to 0, I need to fill my array with 1. After that, when I is equals to 1, I need to fill my array by 2. After that, when I is equals to 2, I need to fill it with 3. After that, I is equals to 3, I need to put it 4 here. After that, I is equals to 4, I need to 5 here. I need to put 5 here. Okay, so we are going to do this with the recursion concept. So we'll from the main program, I will create my array in the main program. After that, I will call my function. As my call my function, at I is equals to 0, I will place 1 in my array. After that, when I is equals to 1, I need to place a 2 value at my second index. After that, when I is equal to 3, similarly I need to put 4 after that, when I is equals to 2, I need to put 3. After that, when I is equals to 3, I need to place 4. After that, when I is equals to 4, when I is equals to 4, I need to place 5 here, right? So my array will initially looks like this. After that, as I backtrack, this is my function calling, right? So from the function calling, when I return to my original source, that is, this is my main is my original source. So as I backtrack to my original source, that is our main function, I need to reduce my array by 2 value. That is, the element which is present is 5. Now this is my array, right? This is my array. How many elements? 1 2 3 4 5. Okay, 1 2 3 4 5. So as I backtrack, so I have reached from the empty array, I have like put all the elements in the array using recursion calls. So I have called all the recursion functions. Now I am backtracking from my endpoint to my original source right now. So as I backtrack from the endpoint to my original source, I need to reduce it by minus 2. So this array will become from 5, I will reduce minus 2 here. So this array will become 3. After this will become 2. After this will become 1. After this will become 0, and this will become minus 1. So this will become like 3 here. After that 2. After that 1. As a backtrack, my values are going to change. After 0, after minus 1. So my final array should looks like this. So I should print my array like this. Okay. So what is the concept here? I hope you have understood that as I like doing function calls, first of all I am placing the elements in my array. After that, as I backtracking from my like endpoint to my original source, I need to reduce my elements by minus 2, right? Okay. So this is the basic asking of the question. Now what is the like concept or the pseudocode of this code? Now of this question. So now I am going to write my pseudocode, that is public static. By writing the pseudocode, you will understand it even more better. So public static void type function, because I'm not going to written anything. After that, let me write the function name, that is change array. In this I'm passing int arr array, after it index int I, after it int value. So which value I'm going to like assign to my how much value I'm going to like reduce in my array. So what is my base case? That is, if I have reached that I is equals to if I have reached the length of the array, then just return. Then first of all I need to like when I reach the base case, so this is my base case, right? So when I reach the base case, what I need to do, first of all I need to reduce the value by minus 2. Here you can see that when I reach the my base case, this is my base case, right? So what I did, I have reduced the value of the value which is present at that particular index by minus 2. So first of all, when I reach the base case, I need to reduce the value by minus 2 by running the loop throughout my array. After return, simple. Okay. So in this I need to run my loop first of all for int j or I, whatever, j should be less than 0 and j should be less than arr dot length after j plus plus. In this we need to print system dot out dot print. First of all I need to print my array, right? I need to print my array, no brackets, yeah, plus parenthesis, that's all, return. So first of all I am printing this array. So when I call my like function calling, so first of all I need to like print this array. So I have like assigned all the elements to my array. I need to show to my user like this. After that, when I reach my base case, I need to like reduce my elements by minus 2. Okay. So when I reach the base case, so this is the base case, right? So I have called all the functions of my stack. So when I called all the functions of my stack, I am printing the array which is like present right here. So when I reach my base case, I will print all the elements right here. After that, what work I am doing? Right? This is my recursion work. So first of all, I am assigning arr of I is equals to value. After that, I am calling change function arr and I am passing my array I plus 1 next index, after that value plus 1. So you can see that initially when I is equals to 2, my value is 1. When I is equals to 1, my value is 2. So what I am increasing? I am increasing the index, after that I am increasing the value. So here value is 1. Okay. After that here initially I is equals to 0 and array is like empty array initially, right? After that here after function calling, when I retrace or when I backtrack, what I need to do, I need to like decrease the element or the value of the elements which are present at that particular index by minus 2. So arr of I minus 2, right? These are the things that I need to do, that's all. So this will be my base case and this will be my like recursion function or recursion like function calling or work, whatever you say, right? Okay. So in the main function, what I need to do, this is my main function, public static main. In the main function, first of all I need to like create my array. of size, I am creating a new array, and all the elements which are in the array of size n are initialized with 0 initially. After that I am calling my function and I am putting the values until I reach my base case. So when I reach the base case, I am backtracking and reducing the value by -2. Okay, so this is the concept here. Okay, so in the main program I am creating my array int arr is equals to new array, new int of size 5, of size 5. After that I am calling my function change array. After here I am passing array after 0th index, after value of 1. So after calling my change array function, I am running a loop and I am printing all the elements right here. So this is the basic pseudocode and the concept of my question. So here what I am doing, first of all, initially I am from the main program, I am calling change array function. So initially my array is assigned with zeros. After that I am assigning the values to my array, that is 1, 2, 3, 4, 5. So after assigning, when I hit my base case, what is my base case? That is my I value will become the array length. If both values, that is the length of the array and the I value are same, then first of all I am printing this particular array. After that I am returning from my main program. Okay, so what is recursion is doing here? Recursion is doing what? After calling all the functions in my call stack, we are tracing back, and when we are tracing back to my original source, I am reducing the values by -2. Okay, after that in the main program, when the control comes to comes back to main program, I am printing the array, and this array will this loop will give me this particular array, and this base case loop will give me this array. Okay, I hope I have understood the concept of backtracking. This is just to build the concept, just to understand the how backtracking works and what are the things that we need to consider when we are doing backtracking problems. Okay, now let us code this thing. First of all, in the main program, I am creating my array int arr is equals to new int of size 5. After that, first of all, I need to create my function public static type function. After that, void change arr, change arr. In this, I am passing my array int arr, comma int index I value, that is after that int value. After that, here what is my base case here? Base case is going to be static, right? Static, yeah. Okay, so what is my base case here? If I is equals to arr dot length, if this is true, if this particular condition becomes true, then first of all I will run my loop for int j is equals to 0, j is equals to 0, and j should be less than n. After j plus plus. In this, first of all, I am printing system.out.print arr of j plus a space. That's all. After that, I am returning. This is my base case. Now, recursion step. In the recursion step, first of all, I need to assign my value to my array. That is arr of I is equals to value. After that, I am calling my function change arr. In this, I am passing I plus 1. After that, value plus 1. After that, what I am doing, I am changing the value, changing the array. Arr of I is equals to arr of I minus 2. That's all. In the main program, first of all, let me call my change function, change arr. I am passing 0 as my index. After that, I am passing 1 as my value. After that, I am printing all the elements which are in my loop or which are in my array. I should be less than arr dot length, comma plus plus I plus plus. In this, I am printing system.out.print arr of I plus a space. So when I run this code, first of all 1, 2, 3, 4, 5 will get print. After that, the reduced value, it is 1, 0, 1, 2, 3 will get print. Okay, so here I need to give in the place of n arr dot length. Okay, now let me save this thing and run. Yeah, let me remove ln here. Let me remove ln here. After here also save this. delete, save and run. Let me here give a next line. System.out.print, that's all. Now again delete and run. So I am like choosing the right order. Yeah, you can see that I have printed the element 1 2 3 4 5 first. So when I reach the base case, from the base case I am printing like all the elements which are there in my stack. After printing, we will study about stack in detail in the next chapter, I guess. Okay, so after reaching the base case, I am backtracking, and as I backtrack, I am reducing the values which are present at my call frame by -2. Okay, so this is the basic backtracking question. Okay, now let us talk about its stack analysis. So this is my like function, right? Now let us talk about its stack analysis. So when I reach my base case, I am printing all the elements which are there in my stack right there. After next line, after that I am returning. Okay, so in the recursion step, what I am doing, initially I am assigning the value to my index. After it, I am calling to the next index, and I am increasing the value of value, that is val, increasing +1. After that, after calling all the functions, I am decrementing the call frame values by -2. Okay, so initially in my main program, I am creating my array of size arr of 5. Okay, so all the arrays, all the elements are assigned by 0 0 0 0 0 0. So initially all the elements which are present in my array are assigned by 0. After that, I am calling my change arr function. So when I call my change arr function, initially I value is equals to 0. At I is equals to 0, I am assigning here 1. First of all, I am assigning at I is equals to 0. First of all, you can see that I am assigning 1. So value will become 1. When I is equals to 0, my value will become 1. Okay, so and at the 0th index I am assigning 1. After here, I will call my change function for I plus 1. So I will call for I plus 1. So I will become 1, and I am changing the value plus 1. So value will become 2. After that, here you can see that I haven't reached to my base case. So here at 0, I will like put here 2, value of 2. So again I will become 2. After that, value will become 3. So at second index, at I is equals to 2, I will put value 3. After that, here when I will become 3, I will put value is equals to 4. Okay, so I will put 4 here. After that, I is equals to 4, I will put value is equals to 5. So I will put value is equals to 5. So you can see that I have reached the base case, that is my I value I will increment, I will become 5, and I have reached the base case. So this will become my base case, and when I reach my base case, what I am printing? I am printing all the values here. The values are 5, 4, 3, 2, 1. So I will print to my user, that is, let us consider this is my output screen. So in the output screen, first of all, I will print 1, 2, 3, 4, 5. So I will print all the elements which are present in my array. After that, after reaching my base case, what I am doing? I am like decrementing as a backtrack. I am decrementing these values by -2. So from 5, I will decrement and do it 3. After from 3, I will like change it from 4 minus 2, that is 2. After 3 minus 2, that is 1. After 2 minus 2, 0. After 1 minus 1 minus 2, that is -1. So when I return to my main program, my array will become like this: 5 minus 2, that is 3. 4 minus 2, that is 2. 3 minus 2, that will become 1. After 2 minus 2, 0. After 1 minus 2, so -1. So this array, this is the changed array, and this will be my final array. So after reaching my base case, my function call will backtrack to my main program, and after my main program, after calling the change function, I am printing all the elements which are there in my array. So when I print, I will get elements like this, that is -1 0 1 2 3. So this will be my final array data, and the elements which are present in my array. So this is the basic question of to build the understanding of backtracking, and this is the question of array implementation using backtracking, or whatever you can say. So this is the question to understand the concepts of backtracking and how backtracking works. So with that being said, let us dive into questions. Hello everybody, now let us talk about our next question. In this question, we need to find the subsets that can be possible, all the subsets that can be possible for the given set. So first of all, what is a set? Set is a collection of objects or collection of elements, and a subset is a part of that particular set. Here the given set is S is equals to ABC, and the subsets that can be possible are A, B, C, AB, BC, AC, and ABC, and finally a empty set. Empty set is represented by phi symbol. It is nothing but null set or null element. Okay, so here the total number of subsets that can be possible for this given set are 1, 2, 3, 4, 5, 6, 7, 8. Total 8 subsets that can be possible for the given set. Okay, so what is a subset? Subset is a part or the element which is a part of that particular subset. So here AB is a part of set, BC is a part of set, AC is a part of set, ABC and phi. These all are the subsets that can be that are the part of the given parent set. Okay, now let us talk about some mathematical stuff here. Let us consider that for a string of length n, let us consider that there are n elements in our set. Okay, so for this particular n elements of set, the number of subsets that can be possible for the given set is 2 to the power of n subsets are possible. Subsets are possible. So this is like kind of mathematical formula to find out the number of subsets that can be possible for the given set. Here n is equals to 3, right? Because there are 3 elements present. So the number of subsets will be 2 to the power of 3, that is 8. And we already seen that how many elements are there? 8 elements. So the mathematical representation for n elements, the number of subsets will be 2 to the power of n. Okay, now let us talk about how we can approach this question. We have understood that user will give us a string. Let us consider ABC, and we need to print all the subsets that can be possible for the given string. Okay, and we already know the formula for finding the particular n elements. If n is equals to 2, then the number of subsets will be 4. When n is equals to 3, number of subsets will be 8. When n is equals to 4, number of subsets will be 16. So it is a increase in the form of 2 to the power of n. So okay, we have understood how many number of subsets that can be possible but we need to print the actual subsets here. Here we need to print all the values of our subset. Okay, we have understood the question. Now let us talk about its approach. So this is the given string, right? ABC. So the basic approach or the basic logic here is that at every recursion point, each character has to make a choice. Either it can be a part of our subset, or either it don't want to be a part of our subset. If it is a part of our subset, then we'll print that particular set. If it doesn't, then we won't print anything. Okay, here the starting character A has to make a choice, that is either it wants to be a part of subset, or it don't want to be a part of subset, that is it doesn't want to be part of our subset. So at each point of recursion, our each character has to make a decision, or have to make a choice. Either it can be a part of subset, or either it won't be a part of subset. It has to make a choice. And in first recursion chapters, we studied that there are 3 fundamental things we need to remember. That is, first thing is base case, second thing is what is the work we are doing, and third thing is function calling. Similarly, in divide and conquer algorithms, we have studied 3 things there, 3 golden rules there. Those golden rules are number 1, first of all, we need to divide our problem. Number 2, we need to find the solution of the smallest problem. After, third thing is combining all, that is conqueror step. So these are the 3 things here. But when it comes to backtracking, there is only one step we need to remember. Backtracking is all about making choices. So at every point of backtracking, we will make a choice, and we will try to find out solution from that point. If it is a wrong path, then we'll go into another path. Okay, so backtracking is all about making choices. Okay, now let us talk about how choices are made, or how subset can be created for that particular given string. Okay, now I am erasing that such that we will understand it even more better in diagrammatic representation. So let us consider that this is our string A, B, C. Okay, this is our string. So we will begin with our first character. So first character, either it will be it will agree that either it can be a part of our substring, or either it won't be a part, it don't want to be a part of our substring. Okay, so if the first character has chosen a path, or chosen that it wants to be a part of our substring, then I am representing it in a box, that is this is our subset. Okay, now I need to make choices for BC string. Okay, so if A don't want to be a part of our substring, then we'll ignore A, and we have to think about only BC. Okay,
Now let us talk about this branch. So A is sorted. For if our first character A wants to be a part of our substring, then I am representing it in the form of box. Okay. Now A is sorted. A wants to be a part of substring. Okay. Now we need to think about B, C. Okay. So talking about B. Similarly, B has also a choice. Either it can be a part of our substring or it won't be part of our substring. Okay. So here, if B has chosen that it wants to be a part of our subset, then A B will be a subset. Okay. If it don't want to be part, then we only need to think about only A will be here, and we only need to think about C. Okay. Okay. Now here C will be also here, right? C will also be here. Okay. Now if now we already know that A and B wants to be part of string. Okay, are you getting it? Now we need to think about C here. Okay, if C wants to be part of our subset, then we need to include all the things, that is A, B, C. If it doesn't want to be part of a subset, then ignore C. After that, just print A, B. Okay. Here, if C wants to be part of our subset, then A, C will be a subset. Okay. If it doesn't want to be part, then only A will be here. So this is the branch. Okay, this is the S step. So if A wants to be a part of our substring, then this is the recursion tree we will get. Okay. Similarly, here if here B has a choice. Here B has a choice. If B wants to be part of substring, then we will include. Let me rewrite here. Yeah. So here B has a choice. If it wants to be part of our substring, then yeah, B, and we need to think about C. If it doesn't want to be part, then we will remain only with C. Okay. Here uh, again C has choice here. C has choice that either it can be part of substring or else it don't want to be part of substring. So these are the two choices we will have. Okay. Now suppose let us consider that C has chosen yes, then we will include B, C. Suppose it don't want to be a part, it has chosen no, then we will only left with B. Okay. If here C has also again character has also a choice, that is if it wants to be part of our subset, then we'll choose C. If not, then we'll choose empty set. Simple. So you can see that we got all the subsets, how many subsets we got in the previous example? For ABC we got 8. Now let us count 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now I want to I will explain you again. That is, at every call, I am making a choice. At every call, a character has to make a choice. That is, what are the choices? Either it wants to be part of our substring, or else it don't want to be part of substring. Okay, each character has a choice. It can make two choices. Okay, I already told you that if it wants to be part, then we'll include it. If it don't want to be part in our subset, then we'll exclude it. As simple as that. Okay, so here we will begin with our first character. So if it wants to be part, then we will include it, and we have to think about BC. Okay, if B also wants to be part in our substring, then we will include B and we'll think about C. If C also wants to be part, then we will include all the characters. If C don't want to be part, then we will left out with AB. That's all. Okay, here this is the path. So this is the recursion tree we will get. Okay, this is the kind of recursion tree. Yeah. Okay, now let me change the string such that let me change the pen such that I will show you the backtracking step. So here we are thinking about C, right? So if C wants to be part of ABC, then we will print ABC and we will return back. If C don't want to be part of our subset, then we will print this part and we will return here again back to our previous function call, and from this we will return here. And from this part we'll think about B. If B don't want to be part, then we'll come here in this path and we'll think about only C. If C wants to be part, then we'll print AC. After it will hand over to again our previous function call, and from the function call another part, and we'll print this, and from this again we'll come back, and this part will be come hand over to our previous function call, and from this back to our original function call, and from the original function call this all part function calling is done, right? Now we need to think about this part we need to think about this part only. So for this part the function call will be called. Okay, so initially we have two choices, that is a b c, and a can be part or a don't want to be part. So if a is the part, then we need to think about bc. So we need to think about first of all b. So if b also wants to be part, then we need to think about c. If c also wants to be part, then abc. If c don't want to be part, then we'll left out with ab. Okay, so here similarly if b don't want to be part, then we'll left out a and c. Similarly if c also wants to be part in our subset, then ac. If not, then only a. Right? Okay, similarly here if a don't wants to be part, then we'll left out with a b c. Now we need to think about b. So if b wants to be part, then we'll include b. After it we need to think about c. If c also be a part, then b c. If c don't wants to be part, then only we will left out with b. Okay, I hope you are getting it. I'm like expanding. I will make the video slow such that you will understand it even more better. My voice is not clear. I hope you got the point here, that at each and every recursion call, each character has to make a choice. That is, either it can be a part of our given subset, or it don't want to be part of subset, and it's the character choice. Okay, okay. So here if b don't wants to be part, then we'll left out with c, and c can be a subset, or c don't wants to be a subset. Yeah, so how many calls? 1 2 3 4 5 6 7 8. So these are the 8 elements. So this will be my base case. So this will be my base case, and these are the total function calling and backtracking steps. Now these might sound like very complex, but let me code this thing and it will be very easy after coding. Okay, now I hope you have got the logic, that at each character, at each function call, each character has to make a choice, that either it wants to be a part of our subset, or it don't want to be part of subset. If it is a part of subset, then we need to think about other characters. If it don't wants to be part of subset, then leave that character and think about other characters. Okay, the logic is very simple. Now let us code this thing. By coding you will understand it even more better. Now here let me write the function for all subsets. So first of all, I'm creating my function public static void type function, because I'm not gonna return anything. All subset. In this I'm passing my string string str, comma our answer. I'm going to create my another string answer that will return my answer. After that int I is the initial index of the string. Okay, so after that, what is my base case here? Base case will be, if our I value is equals to my str dot length. If this condition is true, then here I need to print my answer, system dot out dot print answer. After that, return. As simple as that. So here in the parameters, what I am passing my string, that is abc, right? So I am passing that. After that, I am creating a new string, empty string, such that it will store the all the possible subsets that are that can be like possible for the given set. Okay, after that int I is the initial index, and I will be passing 0 here. Okay, this is my base case. Now let us talk about our recursion step. So this is my recursion step. So in the recursion step, first of all, I need to find out for yes choice. So if the character has chosen yes choice, then I need to call my next string, and I need to add that particular answer in my string. Okay, so I need to call my function, same function, recursion function. I need to pass my string. After that answer plus I need to add that character to my answer, right? str dot caret index I. After it, I need to increase the value of index. That's all, right? After it, if the choice is no, no choice, then I need to call my function and pass the same string and pass the same answer. That is, the answer value of answer doesn't change. but I need to just increase the index, that's all. So this is the simple code for finding all the possible sets that can be like possible for the given set. Okay, so this is the code. First of all, what is our base case? That is, first of all, our base case is we are checking if our I value, that is we are passing initially 0, if our I value is a string, then first of all print answer, after it return. After that, here I told you that every character will make a choice, either it will choose yes, either it will choose no. If it choose yes, then we'll add that particular character to our answer string. Okay, if it doesn't choose if yes, then we don't add and we don't do anything, we'll move to next character, as simple as that. Okay, now in the main program I'm writing my string str is equals to abc. After that I'm calling my uh, function all substring. Here I am passing str and I am passing a empty string. Okay, after that I am passing index I is equals to 0. That's all. Now let me save this and run. You can see that I got all the possible values here. So you can see that in the last I have left with a blank space. That blank space is null character or empty set. Okay, I told you now. So how many strings are there? 8. Yeah, how many subsets are there? 8 subsets that can be possible for 3 elements. Okay, 3 elements of the set. Okay, I hope you have got the logic here. That is, first of all, here in the main function I am creating str is equals to abc. After that I am calling my function. In the function, first of all, my base case is if I is equals to str dot length, then print my answer. After that return, as simple as that. If I didn't hit my base case, then I need to think about making choices. Okay, so what are the choices I'm making? Either yes, either no. If the choice is yes, then I need to add that particular character present at ith index to my answer. Okay, if it choose no, then I need to like don't think about that particular character, move to next character, and for that character think about yes or no. Right, this is the code. This is the code. I hope you got the logic. You got the logic, and you got the approach and the code and all those kind of things. So this is the code for finding all the subsets that can be possible for a given set. Okay, so now let us talk about a similar question, very similar question to this. That is, in the place of finding all the subsets, we need to find the permutation that are the total number of permutations that can be possible for the given string. Now let us talk about that particular question. In this question, we need to find the permutation, all the permutations that are possible for the given string. Okay. So what are permutations? Permutations are nothing but arrangements. So here the given string, we need to arrange all the possible orders. We need to arrange this particular string in whatever the possible arrangement are there. We need to like arrange those elements in all the possible orders. That thing is known as arrangement or permutation or permutation. Permutation. Okay. Okay. Here, first of all, I can write directly my string, that is ABC, or I can like shuffle the values of AB, BC, or I can like shuffle the value of A, B, C, or I can like change the values. By changing the values, I can like arrange the elements differently, and I can get all the arrangement that can be possible for the given string. Okay, so mathematically speaking, there's a formula for finding this type of question. So for n elements, mathematically there's a formula that is let us consider that the given string is A, B, C. Here let us consider that the size of string is 3. Right? The size of string is, here we can see that the size of the string is 3. So how many elements are possible, or how many arrangements are there? 1, 2, 3, 4, 5, 6. 6 arrangements are there. So for given n elements, mathematically they are n factorial permutations that can be possible, n factorial arrangements that can be possible for the given n elements. Okay, so here you can write that for 3 elements, how many ways? 6 ways. That is nothing but 3 factorial. Okay, so this is the formula that we are going to use in this question. In the previous question we have used that is 2 to the power of n. In this we are using n factorial. Okay, so this is the mathematical representation of n elements in n permutation ways. Okay, now let us talk about how we can like do this question and what is the approach for this particular question. So what I told you, that each and every part of recursion, when it comes to backtracking, we need to make choice. Either it can be yes, either it wants to be a part of our string, or no. If there are two different paths, and from the two different paths, we need to make choices, and each choice will give us a solution. Okay, if it doesn't give a solution, then retrace back to your original path and choose a different direction or choose a different path. Simple, right? Remember guys, that backtracking is all about choices, making choices, and if the choice is wrong, then go into new direction and find the solution. Okay, now let us talk about how we can do this particular question. So the given string is a string str is equals to a b c. Okay, now to do this question, I am creating a empty string. Okay, I am creating a empty string. So I am representing our empty string with a blank space, with a blank. Okay, now what I told you, that we need to make choices. We need to make choice making at each recursion step. Okay, okay, good. Now this is my given string, right? A b c. Okay, and this is my blank string, empty string. Okay, so what I do here is that I will reduce the given string and I will remove the particular element from the string and I will add to my empty string. This is my empty string, right? So I will remove the elements from the string and I will add in my empty string. This is the logic that we are going to follow here. Okay, now here this is my blank string and this is my empty string. Okay, now let us talk about its choice making. Okay, initially I can add my a character in my blank string and I will be left out with bc. Good, are we good here? Now this is the step I can follow. Similarly, I can choose b first and I can choose and I can add into my blank space. This is one of the choices. Okay, and we will left out with a c. Or else I can choose c in to add in my blank string and I will be left over with a b. Good. Okay, now let us talk about b. So if I choose b, if I choose to add the value of b or the character b into my blank space, then I will be left out with c. Or else if I choose c, then I will add c and I will be left over with b character, right? Okay, now here in the b, I can choose a and I will be left over with c. If I choose c in the place of a, then I will be left over with a. Okay, okay, now in this case also I can choose b, a will be left here, or I can choose a and b will be here. Now in this case I can choose a and I will get abc, or I can choose b and I will be getting acb, after that bac, after that BCA, and finally CBA and CAB. So these all the permutations that can be possible. How many? 1, 2, 3, 4, 5, 6, and this will be our base case. I hope you have got the answer, that at every point we are making a choice and we will adding the into our empty string by removing the character from our given string. Here you can see that I am removing the character from the str string and I will adding it to my empty string. Okay, here you can see that initially our empty string is empty. After that I am adding a, after that I am adding ab, after that I am adding ac. After that, if I initially add b, I will choose a b, then I will add ba. After that I will be left over with bac, acb, bca, cba and cab. So these are the recursion tree for the permutation like question. This is the approach we are going to follow. Now you can see that uh, if they are like n places, if they are like n places, logically speaking, if you are not like from math background, then we can like think logically also that if I choose to put from n elements, if I choose to put one element in the first, then how many elements are there? If I choose one element here from among n elements, if I choose n, then how many elements will be there? N minus 1. Among n minus 1, if I choose 1, then how many elements will be left? N minus 2. Among n minus 2, if I choose one element, then how many elements will be left out? N minus 3. Similarly, this process will continue until I hit 1. So this is nothing but n factorial. So this is the for n places, the number of permutations will be n factorial. So this is the concept here. I hope you got the concept and the approach for this particular question. Now let us code this thing. Now I am creating my function for permutation, all permutation, all permutation. I am creating my function public static void all permutation. In this I am passing my string str comma empty string that will store the answer. So string ans, that is answer. That's all. So in the function, what is my base case? Base case is if str dot length, because I am removing elements from the str, right, and I am adding it into my answer string. Okay, answer, that is nothing but our blank string. If str dot length is equals to 0, then what I need to do here? First of all, I need to print my answer. After it, return. That's all, return. Now let us talk about our recursion step. In the recursion step, first of all, I am running a loop for I have been I am iterating at each index and I am choosing the each character, right? For iterating at each character, I am running a loop. So for int I is equals to 0 and I should be less than str dot length after I plus plus. In this char current, I am storing the current character. So for initially I am taking A, after that I am taking B, after that I am taking C. So to store the character present at that particular string, I am creating a current character char at particular index I. Okay. Now you can see that I am removing a particular character. Like suppose let us consider that in A, B, C, D, I am removing C. Then what I need to do? I need to change the string. That is, I need to change, if I remove str, then I need to alter my string, right? I need to alter my string, right? Okay, after that I need to add that particular string into my new string, that is answer string here. Okay, now let me write here in the comment section such that you will understand it even more better. That is, let us consider that I have a string a b c d e. Okay, now in this suppose let us consider that I need to remove C among this particular string. So what I can do? I can do like AB plus DE. I can do AB plus DE. So this string, by adding AB plus DE, C will get automatically removed. Okay. Okay. Now these will give me ABDE. Simple. So this is how we can remove the C character, a particular desired character from our given string. So how I can do this? I'm creating a new string new str. So to remove the character from the given string, I'm creating a new string. Okay. After that, here string dot caret string dot substring. So here I am using my string functions. Okay. Here I am using my string functions from 0 to I. After that, what is I here? I is the ith index. Suppose if I want to remove C here, C, if I want to remove C here, then I will be 0 1 2. So I am running from 0 to 2. So I am taking the string, I am taking AB here. So I am giving let us consider that if I want to remove the element or the character which is present at ith index, then I will write substring from 0 to I. So I will be exclusive. It doesn't include the value of I. It will take up to I minus 1. Okay. After that, what I need to do? I need to do plus str dot substring from I plus 1, as simple as that. I plus 1 to up to our string dot length. So it will automatically take up to string dot length. So here you can see that I am performing in the 41th line. In the 41th line, I am performing these particular step. So if I want to like remove a particular character from my given string, then I need to do this thing. So this thing will remove a particular character, ith character from our given string. Okay. I hope you got the logic and you the approach for this question. Okay. Now after removing that particular character, I need to call my function, call my permutation function. In this I'm passing new str and I'm adding the current element to my answer. Save this thing and run. Here let me pass here in the main program, in the place of abc I am passing I am calling my all permutation function str, after it a blank string, that's all. Now let me save and run. So you can see that I got all the permutations. How many? 1 2 3 4 5 6. We already know that there are 6 possible combinations or permutations that can be possible for the given set, okay, for the given string. So this is how we can find out all the possible permutations that are possible using backtracking approach. I hope you got the logic here. That is choice making is the hardcore of backtracking. Now in the next question we are going to see a very important question and very interesting question, and it is more if you think logically, then and only you will get that particular question. I hope you got the logic for subsets, after all the subsets, after permutation, all the possible arrangements that can be possible. Okay, now let us do an interesting question, that is n-queens.
Hello everyone, up to now we have seen different questions related to backtracking, like number of subsets and a number of all permutations or arrangement, whatever you can say, and these sort of questions we have seen, and we have understood that backtracking is all about making choices. Now in this question we are going to do a classical question, which is n-queens. You can find this problem in competitive coding platforms like LeetCode, HackerRank, CodeChef and all those kind of things, and it is the most important question. It is also one of the most important interview questions. Okay, so this is a classical question and it is very important to understand the concept of backtracking. Okay, so in this question, what user or what the question given us is we have a n cross n chessboard. Okay, we have n cross n chessboard. So in chessboard we have like pieces, right? Each piece has its own unique moves. We have pieces looks like this. I'm drawing in very shitty way, but yeah, each pieces in chessboard has unique moves. Like queen has some moves, king has some moves, rook has some moves, and all different pieces like soldier has their unique moves. So in chessboard each pieces has their unique move, and in this question we have given queens, n queens. The chessboard is n cross n and we have given n queens, and we need to place those n queens in such a way that no two queens will attack each other. So to understand the what is being asked in a question and what we need to do and how to find the solution of these kind of questions, let us take an example. That is, let us take an example of 3 cross 3 chessboard. 3 cross 3 chessboard. So suppose let us consider that this is a 3 cross 3 chessboard. 1 2 1 2, and suppose that I have in the question user will give me 3 queens, and I need to place my 3 queens in such a way that no 2 queens will attack each other. If they attack, then that particular position is a wrong position. Okay, got my point. Now suppose if I have taken one queen from one of these 3 queens, okay, and I have placed this queen here. So we already know that if you don't know chess, then there's no need to worry. The queen's moves are, it can move up, it can move down, it can move horizontally, and it can move diagonally up and down. Yeah, so these are the queen's moves. Okay, so if I put my queen in the center of my chessboard, then it can move up, it can move down, and it can move here, it can move here, it can move diagonally also. So if I place my queen in such a way in the center of my chessboard for 3 cross 3 given chessboard, then
there is no other places where I can put my queen. Suppose let us consider that I have placed my first queen here, then I can't place any queen 2, queen 3 in any of these cells, because these cells are in danger. These cells, if I place any of the, suppose let us consider that if I place my queen 2 here, then these particular queen will attack the queen 2. So there are no like certain positions, or there are no like safe positions for my queen. And let us take another example. If you see this example, then you might thought that there are no solutions for this question. Okay, so let us take another example such that it will be even more clear. Okay, let us consider 5 cross 5 chessboard. Now we are considering a huge chessboard such that we can place our queens. Okay, so here let us consider our 5 cross 5 chessboard. Yeah, first 1, 2, 3 and 4. Okay, this is my 5 cross 4. 1, 2, 3, 4. Okay, yeah, 1, 2, 3, 4. 1, 2, 3, 4. Yeah, this is 5 cross 5 chessboard. Okay, suppose let us consider that I am placing my first queen here. So if I place my first queen in this position, then these whole line will be unsafe. After this whole line will be unsafe. Okay, now I am changing my ink such that it will be like even more like attacking of queens will be even more understandable if I change the ink of my pen. So these whole position will be, diagonal position will be unsafe. After this position will be unsafe, and similarly goes with this, okay, so these all positions are unsafe. So here I can place my queen here. Okay, I can place my queen here, second queen here. So if I place my second queen here, it will occupy these certain areas. These certain areas will become unsafe. Okay, so these certain areas will become unsafe. So I can place my third queen here. So if I place my third queen here, then these areas will become unsafe. Yeah, these areas, these board slightly looks like so much messy, but when we are going to solve this question, when you are going to solve this question on your own, you don't need to draw. Like I am just drawing this messy board to just explain you how the attacking of queens works and in which positions we need to place. Okay, so when you are doing this sort of questions, you don't need to like draw the table and draw the chessboard and place the queens and check whether that particular position is right or wrong. You have to think. This is how this is the just a demonstration of my like how I can place my queens in n queens in my n cross n chessboard. Okay, so in this question what is important is, first of all, mathematical terms are very important here. I need to find a logical way. In such a way, I need to find a logical way in which I can place my n queens in such a way that no two queens will attack each other. Okay, so you can see that in the given example I have taken 4 cross 4 chessboard. In the given example I have chosen 4 cross 4 chessboard. So let me change the ink. Yep, yeah, so in this you can see that our first queen is here and this queen will occupy these positions. Yeah, these positions, and my second queen will occupy these positions, these all cells. So here you can see that in the given example no two queens are attacking each other. Okay, here these queens is occupying these positions and this queen is occupying this position. So in 4 cross 4 chessboard, I have placed my n queens, that is 4 queens, in such a way that here no two queens are attacking each other. So let me clear the board. So generally speaking of this question, when it comes to placing n queens in n cross n chessboard, there are three category of these questions. The first category is printing all solutions. Okay, that is nothing but enumeration. Yeah, and the second one is checking whether that particular position or the all in the given chessboard, whether the solution lies or not. The second kind is yes or no, whether the solution lies or not. And the third kind of category in this sort of questions is printing the best solution or giving printing optimized solution. So these are the three kind of things, three category of questions we can have in this N-queens question. Okay, now most of the students consider that printing all the solutions is kind of hard, because we need to print all the chessboards, right? All the possible combinations that can be possible for given N-queens. Okay, so we'll start with this. We'll start with the toughest one, and other questions will become easy for us if we begin with the toughest one. Now let us talk about like what is the approach, what is the intuition we follow to solve these sort of questions. So before we dive into like how we can solve this question and what are the logical things we need to consider, before we talk about like how a particular queen attack another queen, let us talk about one thing, that is rows. Okay, let us consider that this is my chessboard. This is my n cross n chessboard. Okay, suppose if I place my queen here, if I place my first queen in this position, then this whole row, then this whole row will become unsafe. Okay, so my first step is I need to like calculate that I need to the first thing I have extracted from this is, if in the first row or in any given row, if I place my queen in that particular cell, then the whole row will become unsafe. Okay, I can't place that particular queen in that row, so I need to like I need to figure out how I can place my second queen in the second row. Okay, I already placed my first queen in the first row. Now I need to think about like how I can place my second queen in the second row. So suppose if I place my queen here, then I can't place third queen in this particular row. So I can't place my third queen in the second row because the second queen has occupied the second row. So I can't place in the row 2, I can't place my third queen. Similarly, suppose let us consider that I have placed my queen here, third queen here. So the third row will become unsafe for the fourth queen. I am not checking that whether these first queen or second queen will attack my third queen. I am not checking about the moves of that particular queen or the given n queens. I am talking about that if a particular queen I have placed in that particular row, let us consider that there is nth queen and I have placed that queen in the nth row, then the whole row I can't place another queen. I can't place any other queen except that nth queen. Suppose let us consider that I am placing my first queen in the first column, in the first row. So if I place my first queen in my first row, it means that I can't place my second queen in the first row. This is the basic logical thing that I have extracted. Okay, so let us talk about how I am modifying my question. I am slightly modifying my question. If we can solve this question, then we can solve n-queens question. Okay, so here we need to think how I can place n queens. I am slightly modifying my question, that is how I can like place my n queens in n rows. So I am not talking yet about the moves or is it safe to place our queen in that row or not. I am just checking how I can place or what are the possible combinations that are possible to place my n queens in n rows. Okay, if I figured out a way that how I can place my n queens in n rows, after that we will check whether that particular position which I am placing is safe or not. Okay, got my point? Now let me clear the board first. Okay, now let us talk about in this position, in this n is equals to 2, what are the possible combinations that I can place my n queens in n rows. Okay, so let us consider that I have placed my first queen here. Let us consider that I have placed my first queen here. Then I can't place the second queen in this row, so I can place my second queen here, q1, q1 and q2. Okay, so let me draw the board here. So what are the possible combinations? I can like place my first queen in the first column, then this whole row will become unsafe. After that I can place my second queen here. After that, what are other possible combinations? Suppose in the place of first position I am placing my queen, second queen here. So these can be my another combination, that is q1 and q2. suppose if all the columns or all the rows are completed, then I will backtrack. I will backtrack to my first queen and I will check all the possible like combinations for my first queen. So second queen combinations are completed. Whatever the like possible ways we have whatever the possible ways that are there to place our n queens in n columns is completed. Now we will backtrack to my first queen and we will check what are the possible combinations that can be possible for my first queen. Okay, so here I can place my first queen here. After that my second queen here. After that another final possible combination will be I can place my first queen here and the second queen here oppositely. So these are the four combinations that can be possible. Four queens in four rows. These are the total possible combinations for placing my n queens in n columns. Now we are not talking about how a particular queen is safe or not. Here you can see that these if I place this particular queen in the first row, then this position will become unsafe. But we are not talking about safety of a particular queen. We will talk in later part of this video. Now we just need to think about how I can place my n queens in n rows. Okay, now let us code this thing. So for n queens question, first of all I am creating my function public static void type function void n queens. In this I am passing my character board for my chessboard. After that I am passing row, ith row. Okay, after that in this, first of all, what will be my base case? Base case will be base case if row is equals to board dot length. That is if I placed all my queens in all row, then I will backtrack and I will see what are the possible combinations that can be possible for my previous queen. Okay, so this will be my base case. After that here what I will do, I will print board. Okay, print board, I will pass board here. So this print board function will print all the characters or all the values that are there in my board, in my chessboard. After that I will return. That's all. And let us talk about column wise loop. So I will run my loop for int j is equals to 0 and j should be less than board dot length, because here board dot length after j plus plus. You can see that if I place my nth queen in the nth row, then the whole nth row will be unsafe for my other queens. So I need to place my queens in column wise, first column, second column, third column, first column, second column, third column, like this order I need to place. So this whole row will become unsafe if I put my queen here, right? Okay, so let us consider that I have placed my queen here, then this whole row is unsafe for another or upcoming queen. Okay, so I need to think about column wise traversal. Okay, so here in this j should be less than board dot length. Okay, here it is showing some kind of error. Yeah, board board. Okay, RD board. Okay, so in this first of all I am placing my queen here. I am not checking whether the queen is safe or not. First of all I am placing my n queens in n rows. Okay, so a row, after that j is equals to, I am placing my queen here. That's all, capital Q. That's all. After that I am calling my queens for I'm calling my n queens function for n plus 1 for next row. After that I am backtracking board of row of j is equals to a blank space, or you can say dot, you can put dot here. So this is my function calling. This is my function function calling, and this is my backtracking step. Backtracking step. So this is how I can place my n queens in my n rows. Okay, I'm not checking that whether the queen is safe or not. Now let me create a function for my printing board, public static void print board. In this I'm passing my character board BOART board. So in this what I will do, I will just print my chessboard, that is system.out.print chessboard is, and run a loop and print all the elements which are present in my given array, two-dimensional array. I should be less than board dot length, after I plus plus. In this, for int j is equals to 0 and j should be less than board dot length after j plus plus. In this we need to print system.out.print board of j plus a blank space. That's all. After that, here after completing column, I am printing a next line, system.out.print a next line. That's all. Here I need to give static. Okay. After that, here in the main program I am creating my character array char board. So in the main program I am creating int n is equals to 4. After that, character for board array board is equals to new char of size n cross n, that is n and n. After that, I am going to initialize my char board int I is equals to 0 and I should be less than board dot length, after that I plus plus. In this, for int j is equals to 0 and j should be less than board dot length, after that j plus plus. In this I am printing, I am assigning my board values with null, that is board of ij is equals to across, basically across. That's all. And yeah, that's all. Now I am calling my n-queens function. So in this I am calling my n-queens and I am passing 0 board and 0 as my first row. So if I run this code, then this code will print all the possible ways that I can place my n-queens in n rows. Okay, so let me run. Yeah, I need to remove ln. Here printing. Yeah, that's all. Now let me save and run. So these all are the possible ways that are there for printing 4 cross 4 in n rows in n columns. Okay, now let us talk about like is it a safe position to place my queen at that particular position. Now we are talking about safety of that particular queen. So up to now we have seen like how we can place n queens in n rows. Okay, now let us talk about the safety of that particular queen. Like placing that particular queen in that particular position is safe or not. If it is not, then we don't need to place and we'll shift or we'll backtrack and we'll change the position of previous queen and we will check again that whether that particular position is right or not. If not, then change the position of the queen, as simple as that. Okay, now let us talk about how we can choose whether the particular queen is safe or not. Okay, so to understand like placing queens and checking its safety, we need to understand one thing here, that we are using the concept of backtracking. Okay, but I'm like literally screwing, but yeah. So here let us take example to understand how we can place our n queens in n rows or n rows. Okay, so here let us consider a 4 cross 4 board. 4 cross 4, 1 2 3 1 2 3. So this is a 4x4 board. Suppose let us consider that I am placing my first queen here. So if I place my first queen, then I can't place in this row. So in the next column or in the second row, I need to place my queen. I can't place here, I can't place here, and I can place here. So if I place here, how I can place my third queen? I can't place my third queen here because this first queen will attack. I can't place my third queen here because this queen will attack. I can't place here, I can't place here. So at the third queen, at the third row, how many positions are there for placing my third queen on the third row? How many positions are there? 0 positions. 0 positions. So if I get 0 position, that means that my previous queen in the second row, the queen I have placed now, that queen is in a wrong position. So I need to change the position of that particular queen. Okay, so I will backtrack from the third row. I will backtrack to my second row and I will change the previous position of my second queen. So this is my 3x3 matrix. I am drawing it again such that the visualization will be very good. 1 2 3. Okay, so this is my first queen and this is my second queen. So I will change the position of this second queen from there to here. Okay, here this is my second queen. So now coming to the first position is good, second position is good. Now I'm placing my third queen in the here. I can't place my third queen here because this queen will attack. I can't place here, I can't place here, but I can place my third queen here. Okay, now let us talk about the fourth position. So here I can't place my fourth queen here because this queen will attack. I can't place my fourth queen here because this queen will attack. I can't place here because it will attack, and I can't place here because it will attack. The second queen will attack. Okay, so the fourth position is at the fourth position, at the fourth row. How many positions are there? 0 positions are possible because if I place my queen in all the possible positions, it is showing that that particular position is unsafe to place my queen. Okay, it is showing that it is unsafe. That means that in my previous step I did something wrong. So I will backtrack to my third row. From the third row I will backtrack to my second row, and from the second row I will backtrack to my first row, and I will place my queen my first queen in the second position, and I will see that whether that particular position is right or wrong. I will place here and I will see that here if I place my first queen in the second position, then these for my second queen in the second row, these 2 positions, these 3 positions are in danger, are unsafe for my second queen. So I can place my second queen here. Okay, so here I can place my third queen, and similarly here these position are unsafe, but I can place my fourth queen here. So in 4x4 board I can place my n queens, that is 4 queens, in this sort of manner. So here you can observe one thing, that I am checking at each row, I am checking whether this particular position is safe or not. If all the positions are in a particular given row, if all the positions are unsafe, then I will backtrack to my previous step and I will change the position of my previous queen. Okay, and either if I change the queen but again I'm getting the same problem, then I will backtrack to my again original queen and I will change the position of my original queen. Let us consider that I am getting problem in my third row. So I will backtrack to my second row and I will change the position of my second queen, and I will check again that whether I am getting the same problem. If I am getting, then I will backtrack to my first row and I will change the position. I will change the position of my first queen and I will check again that I am getting whether this problem. If no, then proceed, and again I will check for my third row. If not, then proceed. So proceed to my fourth row. So this is how backtracking, coming back to my original position and going forward, works. So this is how we will check whether that particular queen position is safe or not. Now I hope you have got the point that how backtracking works and how we can check that whether that particular position of the given queen is safe or not. So with that being said, let us code the function for is safe. And before we go into the code part, I want to demonstrate one thing, that you can see that we are filling our queens from the 0th row and we are coming down. So one thing you need to understand here, that suppose if I am placing my queen here, so and in my second position I am placing my queen somewhere here. So for second queen, what are the positions or what are the things that I need to consider to check its safety? The thing is, I need to check the upper portion of it, because the queens are in upper portion. You can see that there are no queens in the lower portion, so I don't need to check the safety or the any kind of issues on my downside of my part. I need to check upper position or the upper part of my chessboard. So I need to check that whether the upper part of my given chessboard is safe or not. If it is not safe, then check for another position. Okay, so I will draw the board and I will show you that. Let us consider that this is a 3x3 or n cross n board. So suppose here we have a queen, so we need to check for this part, for this part and for this part. That is the position will be I minus 1. Suppose if the position here is I comma j, then this position will be I minus 1 comma j, and this position will be I minus 1 and j plus 1, and here this arrow at this diagonal will be I minus 1 and j minus 1. So I need to check for my upper part and right diagonal and my left diagonal. So I can if I can able to check that my upper part and my left and right diagonals are safe, then the given position is safe. Okay, now let us code this thing. So in the n-queens function I am going to do a little bit change, that's all. So what is the change? In the for loop, first of all I am checking if my is safe function is returning me true or not. In this I will pass my board and I will pass my row and I will pass that particular row and I will pass that particular column. That's all. I will pass the position of the particular cell and the chessboard. That's all. If it is giving me true, that is safe, then what I will do? I will place my I will do whatever the steps that I am doing, that I was doing previously. Okay, so I will do all these steps. That's all. So this is how. That's all. So this is how I will check that whether the particular queen is safe or not. Now let me create my function for checking whether that particular solution or whether that particular cell is safe or not. Public static void boolean type, because I am returning true now, true or false, that is safe. In this I am passing my character board. After that my int row, after that my int column. In this, first of all I am doing vertically up. I am checking for vertically up, that is I minus 1 j. Okay, so in this I am running my loop for int. I need to check only for row wise traversal, right? So row minus 1 and comma j is equals to column minus 1. After that I should be greater than or equals to 0 and j should be greater than or equals to 0, I minus minus comma j minus minus. That's all. In this I am checking if I encounter any queen in the upper portion, then that particular path is unsafe. Okay, I of j is equals to a queen. If I encountered a queen, then what I will do, I will return false, right, that particular position. So if I encountered, let us consider that I am placing my queen here, so I will check for previous cells, that is vertically up position. I will check in this cell, in this cell if any queen is present, then return false. Okay, this is my vertical up. Now let us talk about diagonal left. Diagonal left up. So in this I am running my loop for int row is equals to I minus 1, after that j is equals to column minus 1. I should be greater than or equals to 0, and j should be greater than or equals to 0. After that I minus minus comma j minus minus. In this same condition, that is, if I found any queen in the vertically left direction, then I will return false. That is, if board of I of j is equals to a queen, then return false, false. That's all. After it, diagonally right up. So for here the row is decreasing but the column is increasing. Okay, row minus 1 and j is equals to column plus 1. After I should be greater than or equals to 0 and j should be less than board dot length. Here I need to give and. Yeah. After that j plus plus comma I minus minus. Okay, in this I need to check if I found out any queen in the position of my in the position tagging position of my current queen, then I will return false. That is, error of ij is equals to a queen, then I will return false. Here I need to give int I is equals to, after it, yeah, that's all. Now let me save, and here I need to give I is equals to row minus 1. That's all. Now let me save and run this code. So you can see that for n is equals to 4, how many, let me check how many possible ways or what are the boards that can be possible. So you can see that here it is showing some kind of error. Yeah, I need to give statement terminator here. And finally, if I checked all the queens and no queen is present in the path of my current queen, then I will return true. That's all. Now let me save and run. Here I need to pass the column value. Here in the place of I need to pass. So here vertically up, you can see that we are not changing the column. The column is same. What is changing? The row is changing. So we'll just need to check for only columns. We don't need to change. We just need to check for rows. We don't need to change the columns because the column is not changing. That's why we don't need to check for columns. Now let me save, and you can see, let me summarize all the things. So in the main program I have created the character board and I have assigned all the things, all the cells with x. After that I have called my n-queens function. In the n-queens function, what I am doing, first of all, I am running a loop and I am checking whether the particular position of my queen is safe or not. And if it is safe, then I am assigning my queen. I am assigning the queen at that particular position. If the position is safe, then I am assigning the value, or I am assigning my queen at that particular position. After that I am calling my recursion function for my next row. After that, here, after calling all the recursion function, I am backtracking and I am placing dot at that particular position. Okay, now coming to the isSafe function. Now coming to the base case. So if I reach my base case, that is my row is equals to board dot length. That is, I have traversed all the rows in all the rows in my all the rows in my board. Then what I will do, I will print board. So these print board function will print all the all the values which is present at my chessboard. Okay, after that in the isSafe function, what I am doing, you can see that in the previous approach method I told you that suppose let us consider that this is my queen. So if I need to place my queen in this position, I need to check whether any queen is present on the top side position or diagonal position. If any of this positions in any of this position, my like another queen is present, then the position is unsafe. Okay, so I need to check the upper portion of my chessboard. So for that, I have run my first loop, that is for vertically up. In the vertically up, I am checking whether that particular here I need to give column, not j. So I need to give column, that's all. Here I am checking that whether the upper part, the straight line upper part of my board is any of the queen is present or not. If yes, then that particular position is safe, then return false. If not, then check for other things. You can see that I am checking for diagonally left and similarly diagonally right, and in all the cases my loop has completed and I didn't return anything. That means that this particular position is safe. So if that particular position is safe, then what I'm going to do, I'm going to return true. Okay, so this is how I'm going to run. So if I yeah, that's all. So this is how is function, n-queens and print board. I am using 3 functions and I am doing n-queens like a question. So this is how. Now let me save this thing and run. Let us see what are the outputs here. You can see that these are for n is equals to 4. These are the 2 possible chessboard that can be possible. Okay, so this is how we can do n-queens question. Initially this question might look too much hard, but break it down into small pieces. So first thing what we did, we found out a way to place my n-queens in n rows. We didn't think about is it safe or not and all those kind of things. We just started with we need to place our n-queens in n columns, n rows. Okay, after thinking about, after placing my n-queens in n rows, we started to think about, oh, this position is safe or not. How we can tell? We can tell by checking the upper portion of my chessboard, vertically up, diagonally up, both sides. So if in these 3 positions, if any queen is present in these 3 positions, then the particular position we are choosing is a wrong position. That particular position is unsafe. Okay, if this is safe function returns true, then place my queen. That's all. That's all. These all are the things. So 3 things: n-queens in n rows, after checking is safe function. If it is safe, then place my queen. That's all. These are the 3 things we are doing using 3 functions. That's all. You can see that these are the possible chessboards that are possible for n is equals to 4 to place my 4 queens in safest place. That's all. Now let us talk about other things here. Let us talk about the time complexity of n-queens question. Here you can see that in the first row, if I place my n-queens, then I need to think about n minus 1 queens. Similarly, for a second position, if I completed the second position, then I need to think about n minus 1 queens combination. So you can see one thing here, that here the total number of ways are decreasing, that is n minus 1, n minus 2. When I place each queen in the nth position, then I need to think about n minus 1 positions, n minus 2, n minus 3, n minus 3, n minus 4 and so on. So these thing will give me n factorial. So the time complexity of n queens is big of n factorial. So this is the time complexity of n queens question. Now let us talk about other things. So if you just want to print how many boards are possible for my n queens, or how many possible ways are there to keep a count, or to print how many ways or total number of ways, you just in the place of print, you just need to do count plus plus. So create a static variable count, and in this if you reach the base case, then do count plus plus. Here I am creating my static variable static count is equals to 0. That's all. I am going to initialize count is equals to 0. After that I am doing count plus plus. Static int count is equals to 0. That's all. Now let me save and run. So how many possible ways are there? Here in the main program, let me print these. Let me print whatever the value returned by my function. So here I am printing whatever the value that is returned by my function. Okay, yeah. Now let me save, and here in this I need to int, yeah, I'm going to change the function return type, because I need to print how many possible ways are there. I don't need to print the chessboard now. For this I need to print the count, how many, like number, the actual number, like how many ways are possible. For that I need to return my here it is showing some kind of error, that is the method must return a yeah, here I am returning count, that's all. Now let me save and run. So here for print the count of the what are the total number of ways that can be possible for given n chessboard. Here I have created a static variable count is equals to 0. After if I reached my base case, then what I am doing, I am incrementing count plus plus. Okay, and finally I am returning my count value, that's all. Now let me save and run. We already seen that for like for n queens, n is equals to when n is equals to 4 cross 4 board, the number of possible ways are 2. In the previous example we have seen. Now let me run this and see whether the code is correct or not. Yeah, you can see that we got our output as 2. So this is how we will print the number of possible ways. What are the possible ways? Okay, the count of the number of possible ways. Okay, so this is how we'll print. Now we have printed all the possible ways, all the possible chessboards that are possible, and we also printed the total number of ways that are possible. Now let us see that whether the solution lies or not. If that particular solution lies, then just return true. If not, then return false. So in the place of int, I am going to create boolean type function. So boolean, and in this I am return true. After that here return false. That's all. Now let me save and run. If n queens row plus 1 returns true, then return true. That's all. Now let me save and run. Here I need to remove statement terminator. Save and run. So here I have created a boolean type function because I need to print whether the solution lies or not. Okay, so for that I have created my boolean variable. After that, if I hit my base case, then I am returning true. If I didn't hit my base case, or in the old function calling I didn't like got any of the like pairs or the queens, I didn't placed my queens, then I will return false. If I placed my queens, then I will return true. Now let me save. We already know that for n is equals to 4 the chessboards are possible. So if I run this code, then it will show me true. Okay, now let me save and run. Yeah, you can see that we got output as true. So this is how we'll print all the chessboards, print the count number of like value for how many ways are possible, and print whether the solution lies or not. So these are the three kind of things we have seen. So this is the n-queens question. I hope you got the like all the things up to now. Now let us talk another interesting question, which is very simple. If we understand the n-queens, if you didn't understand any things in the n-queen question, then repeat it again, you will surely understand. Okay, now let us do another interesting question, that is grid ways. Now let us talk about another important question, that is grid ways. So in this question, user will give us a source, this is a source, and a destination. Let us consider that this is our destination. So user will give us a source and a destination, that is 0, 0, 0, 0, and n, m, or n minus 1 or m minus 1, whatever we can say, that is the representation, that is n minus 1, m minus 1. So this is my source and this is my target, and we need to tell user that how many ways are possible, how many number of ways can be possible to reach from my source to my destination. This is the asking of my question, and here is a condition. Here in this question we will have a condition, that is either I can go towards right or I can go towards down, but I can't go up or left. Okay, suppose let us consider that I am taking right first of all, after that I am taking down, after that I can't take left, because there are only two possible ways are there, that is either right or either down. I hope you have understood that either we can move right towards right or we can move towards down. That's all. That means that I can start from right and come to down. After that I can like move right, come down, that's all. Like this is one of the ways, this is one of the possible ways. Okay, so like this way we need to find how many total number of ways that can be possible to go from my start position to my end position. I hope you got the question. Now let us talk about like how we can like solve this question. Now let us talk about the approach of this question. So this is my starting point, this is my starting point, okay, and this is my ending point. So first thing I want to tell you here, that what I told you, that backtracking is all about making choices. At every point of recursion we make a choice. Here what is the condition, what is the choice I am making? The choice is either I can move right or I can move down. So there are two choices, either I can move right or I can move down, so these are the two choices I will make at each respective step. So let us consider that I have chosen to move towards right. So if I move towards right, then what will happen? Or let us consider that I have chosen down. So if I move towards down, then what will happen? So to show what are the things that will change, let me change the pen. So here I am going to change the pen towards black, okay, to black. Okay, so suppose I have chosen my step as towards right. So if I choose my step towards right, then I don't need to think about this remaining part, because this whole column I can't come back, because I can't go towards right. So all I need to think about is this portion, of grid. So if I can able to find the number of ways for this possible grid, then the question is sorted. Suppose if I have chosen to move towards down, my first step as down, then I can't come towards back, so I can't reach this row. So all I need to think about is this grid part, this small grid part. So if I calculate the grid part, let us consider that this is grid part G1 and let us consider that this is the grid part G2. So if I can able to like calculate the total number of ways that are there in G1 and G2, then the total number of ways will be total number of ways for the whole grid will be, total number of ways is equals to number of ways of G1 plus number of ways for G2. So if I sum these two things, then I can calculate the total number of possible ways that are there in my whole grid. Okay, I hope you got the thing, that when I make the choice, my grid will get reduced, and again when I make choice, again my grid will get reduced. So by reducing the grid, by reducing the size of my grid, I can calculate the number of ways. And when I calculate the like number of ways for my smaller grid, that is a single cell. So if I calculate the number of ways for my smaller grid, that is the smallest grid is nothing but one cell, and that will be my base case. So if I can able to find the smallest grid, or you can say one cell number of ways, then from that base case I can backtrack, and by doing backtracking I can calculate the total number of ways. I hope you got the like logical part of this question. Now what I told you, that at every cell what we are doing, we are making choice. Either let us consider that the cell is x comma y, the position of the cell, present cell is x comma y. So if I choose to move right, then what is going to change? The row will be same, but the column will increase. Okay, so here the row will remain the same, but the column will change. Okay, if I choose towards right, then column will change. If I chose to move towards down, then what will happen? Column will be same, but row will change. Here x plus 1 comma y. Okay, so these are the things. So from this, can I extract my like equation, recursive equation? My recursive equation will be recursive equation, that is, let us consider that total number of ways is T of let us consider it as a function, that is f of x comma y is my total number of work. Okay, total number of ways that are possible. Okay, here I can write that my right side, if I add my right side ways plus my left that is downside ways. So if I add these two, then these two things will give me the total number of ways. So can I write this as recursive in a recursive equation, that is f of x comma y is equals to f of x comma y plus 1 plus f of x plus 1 comma y. So this is my down and this is my right, down, right. Okay, so this is how I can, this is my recursive equation for this particular question. So what I am doing here, you can see that here either we have two choices, either I can move right or I can move down. If I choose to move right, then I need to think about these G1 array, okay, G1 grid. So if I choose to move down, then I need to think about G2 array. I hope you got my point. That is, at every choice making, my array will get reduced, and this reduction will continue until I hit my base case. What is my base case? Now let us talk about base case. We have talked about recursive equation. Now let us talk about my base case. So let us consider that what is the smallest grid here. This is my smallest grid. So to reach smallest grid, suppose if I am here, so I have two choices, right? I can move here or I can move here. So if I move here, then I will come out of my grid. Okay, so number of ways will be 0 here, and here number of ways will be 1. Suppose let us take that I am here, I am in this position. So if I move here, then I will come out of my grid, so number of ways will be 0. If I come down, then number of ways will be 1. Okay, so for if my source is equals to n minus 1 comma m minus 1, so my source position is equals to m minus 1 comma m minus 1 comma m minus 1, then that is my target. So when I am at the target, then what I need to do, I need to return number of ways as one way. So this will be my base case. Suppose let us consider that let us consider a small case scenario that I hope this black pen is visible to you. Yeah, 1 2 3 and 1 2 and yeah, let me clear this thing, let me clear, let me choose eraser. Black white pen will be much more visible. Okay, so 1 2 1 2. Suppose let us consider that I am here, I am in this position. So if I go down, then I will come out of my grid, number of ways will be 0, and here if I choose to move right, then number of ways will be 1. So this thing will give me 1. Okay, after that if I am here, then if I move towards right, then number of ways will be 0 because I will be coming out of my grid. Okay, now if I come down, then the number of ways will be 1. So for this path, number of ways is 1. Suppose let us consider that I am here, so I can move here and I can move down. So number of ways will be for this particular thing 2. So this is how I am going to calculate the number of total number of ways for my grid ways. How I am going to calculate? I am going to calculate using this recursive equation. So this recursive equation or this thing will give me the total number of ways that are there for my grid n cross m grid. So I am going to create the function for grid ways, that is public static integer type function, because I am going to return the number of ways, right? So grid ways, in this I am passing my array int grid, 2-dimensional array. After that int n value, int m value, that is my sizes. Okay, in this let us talk about my base case first. Showing, yeah, so first of all my base case. So base case will be if I is equals to n minus 1 and j is equals to m minus 1. That is, if I am hitting my last cell index, then they are only one way. So in this what I need to do, this is a condition for This is a condition for lost cell. So in this I need to return 1. That's all. This is my base case. After that, let us talk about my else path. So if I am not hitting my base case, but I am coming out of my grid in that if I is equals to n or j is equals to m, then return. In this case there are no ways, so in this case we need to return 0. Here here in the place of grid we need to pass the starting index and the ending index, that is I comma int j. That's all. These are my starting indexes ij and these are my ending indexes. Okay, so after that, after else if statement, we need to do our recursive step. So what is our recursive step? Our recursive step is, first of all, we need to calculate the work 1, that is for if I choose my right path, then what the number of possible ways for my right path grid. Okay, so here int w1 work 1 is equals to grid ways, and I just need to increment I plus 1. That's all. And for my work 2, if I choose to be like go down, then I need to like change the column, that is I plus 1. Yeah, that's all. And finally what I need to return is work 1 plus work 2. That's all. So this is the question for calculating the number of grid ways for the total number of possible paths that are there for my given grid. Okay, so in the main program I am going to clear all this thing. Now in the main program I am going to give int n is equals to 3. After that m is equals to 3. After that I am printing system.out.print. I am giving 0 comma 0. After that n comma m. That's all. Here I need to call my function, yeah, grid ways, and remove all this. 0 comma 0. So let me run this, let me save and run. So let us see for 3 cross 3 matrix, what output will get. So let me run this. You can see that we got the output as 6. So let us dry run, and this is the code. This is the code for calculating the grid ways of the given grid or array, 2-dimensional array. So here in the main program we are passing the size or the target cell of my given grid. After that we are passing the source position, after that our ending position, that is our target cell, and these code will return the total number of ways that can be possible. Now let us see how we got answer as 6. So this is my given 3 cross 3 grid, right? So initially when I am in this position, this will return me 1. So when I am here I can move right, so this is my one path, and when I am here I can move here, so this is my another path. So when at this position you can see that the number of paths I can move is left and down, that is 2 total number of ways in this particular cell. So talking about this particular cell, I can't move down. If I move down, then I will come out of my grid, so their number of ways will be only 1. When I am here in this condition, I can move only down. I can't move towards right, because if I move towards right, then I will come out of my grid. So here number of ways will be 1. After that, talking about this thing, here you can see that I can move right down. After that, here I can move right down. So here you can see that when I move right or when I move down, so these are the two paths, that is 2 1 and 2 1. So we can calculate the grid number of grid by, like what I told you, that reduction. So by reduction we will get answer as for this 3 3, and for our source cell will get the answer will be the sum of these two paths. So 3 plus 3, our answer will be 6. Now I can show you the total number of ways also, though. So my first way will be, I can move right, first right, after second right, after that I can move down. Let me clear this such that it will be like very much clear to you. So here let me clear all those things. So here first of all I can move right, move one step, after that another step, I can move down, after that another down. So from this this is one of the paths, and the second path will be first of all move right, after that move down, move right and move down. And the third path will be first move right, down, down, right. And the fourth path will be down, right, right and down. And the fifth path will be down, right, down, right. And the sixth path will be down, down, right, right. So these are the six possible ways that are there to travel from my source to my target. So this is how the total number of cells or total number of ways are there to move from my source to my destination. I hope you got the logic, you got the pseudocode and the actual code and all those kind of things. And up to now we have like completed all the important questions related to backtracking, like calculating the number of subsets, permutation of characters, and n-queens. We have seen different variations of n-queens, grid ways. And there's also an important question which we are not covering. I want you guys to do it by yourself, that is Sudoku solver. So using backtracking you should solve the concepts are very much same, that is at every point of recursion we make a choice. So by making choices we'll like we'll go that particular way. If that particular way is wrong, then we'll backtrack. So using recursion we'll backtrack. So this is how the backtracking works, and I want you guys to do Sudoku solver, because I don't know like how to do Sudoku. I haven't played Sudoku once in my lifetime, so I don't know that kind of questions. But yeah, if you are interested, then check it in Google and understand the code and the working of Sudoku. So by understanding the working of Sudoku, you can solve the question easily. So up to now we have covered all the questions related to backtracking, and we are going to start our next chapter, which is very easy chapter, that is array list. So with that being said, I will see you in the next one.